Greetings, colleagues. Let's talk about an important weather phenomenon in this short video presentation. Let's talk about the fronts. Fronts are mostly responsible for the changes in weather like cloud formation, low visibility, precipitation, turbulence, and much more. Every pilot is required to have a general knowledge and understanding of different types because the weather associated with the fronts has its effect on our flights. So let's start from the general definition of a front. How do you define a front as a pilot? A front is the boundary line between two different air masses. What's an air mass? An air mass is a large volume of the air, and we all know that the air masses do not have the same characteristic, meaning that they do not have the same temperature, the same moisture content, and the same speed and movement. Some air masses are very cold and dry, and some air masses are warm and moist. The characteristics of air masses depend on where they had first originated or where they had first started and over which type of the land they had moved. For example, an air mass can originate in the North Pole and later move towards the south, or an air mass can first originate in the west and later move towards the east. If an air mass moves over cold lands, then the air mass will absorb the temperature from the cold lands and it will become cold and dry. But if an air mass moves over warm lands and seas, besides picking the temperature, it will absorb the moisture and the air mass will become warm and moist. If two air masses of the same nature and same characteristic meet each other from different directions, fronts will not be made. But if two air masses of different characteristics, like different temperatures, different moisture contents, and different speed and movement meet each other from different directions, then the fronts will be originated. Mostly we have four types of the fronts, and they are the cold fronts, warm fronts, stationary fronts, and occluded fronts, and they create varying weather patterns. So colleagues, let's take the first type, the cold fronts, has a priority and talk about the general specifications and general characteristics of the cold front. But before this, important points to know about each type of the front are the weather associated with the front, type or types of the clouds which will be formed, type of precipitation to expect, and the general direction of movement of the front together with the wind direction and changes in temperature and pressure to expect, and much more. Coming back to the cold fronts, a cold front is a boundary where a cold air mass displaces a warmer air mass. Displacing the warm air mass will cause a sudden drop in temperature. So this is the first indication of approach of a cold front to a station, sudden drop in temperature. It will cause strong winds and often heavy precipitation, including thunderstorms and potentially severe weather. Because cold air is very dense, it sinks under the warm, less dense air and pushes the warm air up. The boundary between two air masses are steeper and more abrupt. Cold fronts generally moves faster than the warm fronts, and the only type of the front which has very fast movement is the cold front. And because of the fast movement, cold fronts will not stay longer, and the weather associated with the cold front will not last longer. Cold fronts mostly move from the west to the east, or we can say that we should mostly expect a cold front to reach a station from the west. Cold fronts will cause the temperature to drop, as we said before. Besides drop in temperature, you should expect strong and gusty winds. Precipitation will be very heavy, including thunderstorms, and the type of the precipitation to expect will be heavy rain, hail, and snow. Tornadoes may also form when a cold front approaches a station. Based on the general characteristics of the cold fronts that we talked, now what type or types of the cloud formation we should expect from a cold front? Please remember that warm and moist here is pushed up ahead of a cold front. When warm moist here is pushed up, towering cumulonimbus clouds associated with thunderstorms will be formed. So this way, formation of cumulonimbus, towering cumulonimbus, and towering clouds will be formed. Another problem associated with the cold fronts is the formation of squall lines, which are long bands of the thunderstorms. Once the cold front passes a station, what happens? As we said before, the cold front was there over a station with heavy precipitation, strong winds. But once the cold front passes the station, what happens? The skies will become clear and the air remains cooler and drier. Strong gusty winds are also associated with the cold front. It is good to know the general direction from where the winds will blow. In the northern hemisphere, wind direction will be shifted. That's going to be a shift of the wind direction. That's going to be from the southwest to the northwest, or a process of the clockwise varying. Cold fronts are typically represented by a solid blue line with the triangles in the weather charts. So the triangles are pointed towards the direction of the movement of the front. So colleagues, now let's talk about the second type of the fronts, about the warm fronts. A warm front occurs when a warm air mass displaces a cooler air mass. So displacing the cooler air mass by warm and moist air will cause the air temperature and humidity to increase. Different cloud layers in different altitudes will be formed. Precipitation in this case will be light, including rain and drizzle. As we said before, as the warm and moist air approaches a station, it will ride over the cold air mass. Why? Because the warm air has lesser density than the cold air. So how possible that a lesser dense air displaces a more dense air? That's not possible. Because of this, the warm air, instead of pushing under the cold air, it will ride over the cold air. In this case, we will experience warm air above and cold air below. This will cause formation of a thick layer of the cloud associated with continuous light precipitation and low visibility, and the clouds will be covering a wide area of the land, and at higher altitudes we will experience icing conditions. Ahead of a warm front, you will see high clouds like the cirrus and cirrostratus, but as much as the front approaches the station, the type of the cloud will be altostratus, and even nimbostratus will be formed. Important to know about wind direction and barometric pressure changes as the warm front passes a station. Mostly, wind will not have a specific direction and speed, and wind will be variable with very little gusts. Some great changes in barometric pressure will occur. Atmospheric pressure will first fall, then it will rise slightly and will continue to fall until the warm front passes completely. On weather maps, warm fronts are represented by solid red line with red semicircles along the line, which indicates the direction of the warm front movement. Now, we take the third type of the front, which is the stationary front, into our consideration. Stationary fronts originate if two air masses meet and neither is strong enough to displace the other. This will result in prolonged periods of the cloudy and potentially wet weather. Stationary fronts mostly do not have horizontal movement. Because stationary fronts do not have movement, the front will stay stationary for a long period of the time, causing cloudy weather for extended period of the time. The weather condition will be a mixture of the cold and warm fronts, or in other words, we can say that we may experience the weather condition has a mixture of both fronts, including rain, and sometimes has showers or continuous rain or drizzle, snow and shower snow, including low visibility, and most especially during the morning times. Okay, colleagues, what do you think of the wind direction in a stationary front? Wind mostly blew parallel to the frontal zone, so this will help to prolong the stay of the stationary front for a long period of the time. On weather maps, stationary fronts are shown as alternating red semicircles and blue triangles, with red semicircles pointing in one direction and blue triangles in another direction. The last type of the front that we should discuss is the occluded fronts. An occluded front occurs when a faster moving cold front overtakes a slower moving warm front. This will cause the warm air to be lifted in some areas, meaning that the warm air will not be lifted all, resulting in a complex weather pattern associated with heavy precipitation and strong wind. Occluded fronts can be either cold or warm depending on the temperature of the air masses involved. So in this case we have two types of the occluded fronts, either cold occlusion or warm occlusion. In a cold occlusion, cold front overtakes warm front, and the air behind the cold front is colder than the air ahead of a warm front, causing the warm air to be lifted and occluded. But in a warm occlusion, the cold front again overtakes the warm front, but the cold air behind the cold front is warmer than the air ahead of the warm front. This will cause the cold air to be lifted and occluded. What type of the cloud formation we should expect from a occluded front? Occluded fronts are mostly associated with cloudy skies and heavy precipitation because the warm air lifted cools and condenses. The type and intensity of precipitation depends to the type of occlusion and the moisture content of the air masses. Concerning the wind direction in a occluded front, as the occluded front passes, wind direction and speed can change, potentially leading to strong winds. What kind of the temperature change we should expect in a occluded front? Will it be from cool to warm, or will it be from the warm to cool? Temperature can either change to cool or to warm as the front passes, because it depends to the type of the occlusion and the air masses involved. Coming back to the symbol of a occluded front in a weather map or weather chart, this type of front is represented by purple line with alternating triangles and half moons pointing in the direction of the front's movement. So, okay colleagues, hope watching my short video presentation helps you build a general understanding and knowledge about the fronts. In my next video presentation, we will discuss, based on your request, about runway lighting system that will be presented to the new pilots and the pilots with less experience on night flights. Thank you very much, and we'll see you back in my next video presentation.